This is the solubility curve video that's due Monday, so make sure you bring it in with your notes. And what this curve that we're talking about, so label this solubility curve. I should do this. Solubility curve. Okay. It talks about how much can dissolve. Everything up to this point has been what will dissolve. Okay, so here's what I want you to write down. Solid solute as the solubilities generally increase as the temperature increases. So as the temperature increases, the solubility increases. Okay. Pressure, don't really need to have this down for right now, but just know that it really doesn't have an effect. Gases, the solubility generally decreases as temperature increases. Okay. We kind of already talked about that. Solubility generally increases as pressure increases. This is more for gas laws, but just to kind of give you a heads up on it. Okay. So make sure you write those things down. The types of solutions that we have, there are 3 ways to classify a solution: unsaturated, saturated, and supersaturated. Don't write this down yet because it's coming up right here. Oops, this one. Okay, so an unsaturated solution is a solution in which more solute can dissolve. So if you look here, you have unsaturated. Okay, so here's what happens. It's below the line, or we're going to say under the line. So it's below the line. Here's what it looks like. You have a solution and you add some sugar or something to it, or a solute to it, and you stir it up and the solute looks like it disappears or gets dissolved. That means it still is unsaturated. Okay. Saturated solutions. Saturated solutions are solutions in which they contain the maximum amount. Oops, right here. I don't know why my pen's doing this, but it's doing something weird. But maximum amount of solute. Okay, so maximum amount of solute. Why am I getting such crooked things on here? All right, I'm not sure what it's doing, but it's going all crooked. But it is on the line. Okay, so that means in just a minute. So on the line. Okay, here's what this looks like. You have a solution and you put some more solute in there, you stir it up, but all the solute ends up at the bottom. That means that it's holding as much as it can at a specific temperature. Supersaturated, okay? Supersaturated holds more than the maximum, okay? So this one I use Superman, because where does Superman usually spend most of his time? Above the line. Okay, so he flies in the sky. All right, above the line. And here's what this looks like. Okay, so we've supersaturated a solution. We add a couple of crystals in there, and we end up getting very different shaped crystals because the solute starts to fall out of solution slowly, or sometimes very, very quickly. Okay, so supersaturated solutions. This is just an example. You don't have to write this down. But a supersaturated solution is holding more than it can hold. And we do this by heating it up and adding as much solute as we possibly can. And then we cool it down slowly. And when we do that, crystals start to fall out of solution. An example of this is rock candy. Okay. You can also make borax crystals for Christmas, and I'll talk about that if you want to know what that means. Okay, so they are very unstable and it's only temporary. They can't stay in there forever. Okay, and here's a video of a supersaturated solution. If you notice that in the video, it's there's liquid in here, and when you pour it out, it's very unstable and all the crystals form. Okay, it's pretty cool. I wish we had the solutions to do that in class so I could show you. But I don't believe we have any. Okay, this is our solubility table that we've used before, and this only tells us what substances will dissolve. What we're going to talk about now is how much can dissolve. And solubility indicates the amount of solute. So when we talk about solubility, It indicates the amount of solute that will dissolve in a given amount of solvent at a specific temperature. Okay, so this is key, right? And on the x-axis, we have temperature. So down here, we have temperature. And over here, we have our y-axis, and it's how much will dissolve. And here is something you need to know. It's 100 grams of water. Okay, so various lines, each line represents a different solute. So if I'm looking for KNO3, I just look at this line right here. Okay, and I will be giving you this on a test because you're not going to draw it out or memorize it, okay? All right, so let's take a look at what that means. Okay, so solubility curves. Solubility is as a function of temperature. So what I was talking about above the line, on the line, and under the line. Let's take KCl right here, this one right here, okay? That orangish line. If you at 30 degrees Celsius and approximately 38 grams, it's going to be on the line, and that means that it is saturated. If anything falls above the line, a dot, let's say I'm at 30 degrees and I'm at 50 grams right here, then now I'm above the line and it's supersaturated. But I'm at 30 degrees and 20 degrees Celsius, 20 grams, now I'm below the line and I'm unsaturated, okay? So let's take a look at this. Using an available solubility curve, classify these as saturated, supersaturated, or unsaturated. Well, if I'm looking at 80 grams of NaNO3 at 30 degrees Celsius, I go and find that line. And NaNO3 is this here, right here. Okay, so what do? I go find my point on my graph, and it is falling below the line, so it is unsaturated. When you have 45 grams of KCl, so now here's the line we're looking at right here, KCl, and we're not looking at any line but that one right here. Okay, so we go 60 degrees Celsius at 45 grams, which is approximately right here. And so let me draw my little dot here. All right, and so it falls on the line, so we are saturated. Okay, the next one is 30 grams at 30 degrees Celsius, KClO3. It's this little bluish, purplish line here, and we're going to draw our dot, and there's our line, and it's supersaturated. And the last one, looking at PbNO3 too, and here's our dot, here's our line, it is underneath, so it's unsaturated. Okay, sorry, this video is going to go a little long. Sorry about that, guys. Describe each solution below. Per 100 grams of water. Well, this whole chart is only 100 grams of water, so I'm looking at 100 grams of NaNO3 at 50 degrees Celsius. So here's 50 degrees Celsius. Here's 100 grams. Put our dot there. Oops. And we are looking for NaNO3, and it's going to fall under the line, so we will be unsaturated. All solute dissolves, clear solution. Okay, so cool solution A, very slowly to 10 degrees Celsius, and you end up with a supersaturated solution. Why? Because the 100 grams moves over to 10, and now we're above the line. Now we're supersaturated. Quench solution A in an ice bath to 10 degrees Celsius, and you move it over. Okay. Now, it's a saturated, extra solute, 20 grams, can't remain in solution, can be visible. Okay, that's basically what happens. All right. So, how to use a I'm going to actually stop this video, and I'm going to tell you how to use it in another